Yeah. Okay, so some quick reminders before we go on. What do we call that guy? In exponents, he's the base. What is he in radicals? Does anybody remember? Radicand. So just to remind you, this whole thing, actually, I'll do that in a minute. We'll remind everybody what everything is first. The radicand. Does anybody remember what that guy's called? That's what we say. We say root, but its name is the index number. And then this guy is the coefficient. Now, if we were to write this as an exponent, it would be ax to the 1 over n. Everybody cool? The x, the base. Oh, I've lost my little highlighty guy. The base became the radicand. The fraction became the index, and we wouldn't write 1 there. And the coefficient still stayed the coefficient. Yeah, we're all good? All right. We know what a radicand is. We were dealing with that in the last unit, the very end of exponents. This index number, most of you probably forget what that means. The index number tells you the number of equal factors of x that you seek. So whatever that number is, that's how many you're going to pull out of here. So if it was no number, it's 2, right? And we would be looking for 2 equal factors of x. So just to remind you of ones you can do in your head, square, no number there, square root of 4 is 2, because 2 times 2 is 4. We're all good with this, right? The cubed root of 8 is what? 2, because 2 times 2 times 2 is 8. We're pulling out a group of 3. Everybody remembers this, right, from the 10th grade? Okay, so now, 2 words. An entire radical, 2 terms, I should say. An entire radical is just a radicand. A mixed radical is a coefficient. And a radicand. We are usually 99% of the time, we are trying to get to mixed radicals because this is simplified. This is our goal. Okay? Good job. Slide to the right. A little further. I'm sure Bea will not be worried about it. Now you can see, right? There you go. I do apologize again. I will work on other solutions, but until such time as I find another solution, we're stuck with this. So, 72, we want to convert to a mixed radical. We want to simplify it. Simplify, remember, in math, almost always means get the smallest numbers involved, right? When you simplify a fraction, 12 over 16, you want smaller numbers, 3 over 4, right? Same thing here. Now, some of you probably remember how to do this, and some of you, based on the end of the exponent unit, don't remember how to do this. Is there anybody that fully remembers what to do with this? I got one of these. Everybody, 2? Okay. So, the way to do this, there's a way to do this that will always work, but will take a long time. I'm going to show you that, and then I'll show you the shortcut. Everybody cool? All right. Yeah, you make the tree. So you start with 72, and you break it down into factors. So what are the first two factors you will choose for 72? I'm betting almost all of you will choose the obvious one, which is 18 times 4. Right? No, of course not. You mostly chose, I bet every single person in the room put 8 and 9 or 12 and 6. Is that right for everybody? Okay, it doesn't matter what you put. If you put something other than that, don't change it. Trust me. I'm going to put 18 and 4. Now, those are not prime numbers. We are seeking prime numbers here. So I break it down again. 4 becomes 2 and 2. 18 becomes 2 and 9. 9 becomes 3 and 3. And you can see that I have 3 prime numbers there, 2 prime numbers there. And the square root of 72 is the same thing as the square root of 2 cubed times 3 squared. 2 cubed is 8, 3 squared is 9. Everyone is cool, yes? Now, is there an index number here? There is, but we don't write it. What is it? 2, which means we are looking for groups of 2 factors. Can I get a group of 2 out of that? Yes, but there will be one remainder, right? So I'm going to bring out a 2, and I'm going to leave a 2. Can I get a group of 2 out of that? Yes. Will there be any remainders? No. So I'm going to bring out a 3, and there are no remainders, so I don't write anything there. Now, I have root 2, because that's what I left under the radical sign. These are now out in front, which means they are coefficients. What do coefficients do? Multiply. So what do I get? 6 root 2. Everybody remembers this now? Good. Now, of course, the shortcut is the root of 72 is the exact same thing as the root of 36 times 2, isn't it? If I go with the root of 36, I can stop right there, because what is the root of 36? 6. So I can bring out that 6, and I'm left with 6 root 2, and it saves me a lot of steps. So if, when you are breaking down your radicand, any of these branches hit a square, like 4, you could stop. So in the shortcut version of things, which I will do in pink, I might, if I went 18 and 4, I would stop at the 4. And then I would go 2 and 9, and I would stop at the 9. Because then I would have the square root of 9 times 4 times 2. Square root of 9, square root of 4, and I leave a 2 under there. Everybody cool? Yeah? Okay. So 99 is an easy one to start with. Ooh, I'm getting a warning. Did I get a good night's rest? It's supposed to rain today, so I should take care to get my steps inside. I need to walk 7,888 steps in the building today, according to LG. Tells me that every day. I can't seem to make it stop. I tell it not to. But. All right. So 99, we break it down. What's the first one you're going to use? 11 and 9. And we can stop there, right? Why? 11's a prime number and 9 is it's got a square root. So I take the square root of 9, which is 3, and I leave the 11 under there. I leave the 11 under there. I leave the 11 under there. Thank you. You've been in the class before. It shouldn't have taken that long. All right. What about the next one? Most of you, it ends in 5, would probably divide by 5, right? I wouldn't, though. I would make that 25 times 3. Why would I use 25? Because it's a perfect square. So what's coming out? 5. Now let's pretend that you didn't do that. You said, oh, it ends in 5. I'm going to divide by 5. So 75 would be 5 and 15. And then you would break that down into 5 and 3. And there's your pair. Do I care how you do this? If you want to make the whole giant factor tree, is that okay? Do you have to draw the factor trees the way I draw the factor trees? No. If you were in my class in grade 10, you know that I personally do not do my factor trees this way if I'm doing a big number. I do something that looks like stairs. But whenever I show that to kids, kids are like, what? And then I show them this, like, oh yeah, factor trees. Mrs. Rag Crumble did those with us in grade 6. Okay? Okay, so you do 80. Go. I bet most of you will use 8 and 10. And then you must continue both of those branches, yes? Because neither 8 nor 10 is a prime number, nor are they perfect squares. I will wait a moment for everybody to get done. And then I, of course, would have used 16 and 5. Why? Because 16's got it's got a square root. 4 root 5. Because I am better at multiplication. I did not stop my multiplication at grade 10, or at 12. But you would get the same result if you went 8 and 10, wouldn't you? Because you would have gone 8 and 10, 2 and 4, probably stopped at 4, 2 and 5. So 80 is 2 squared times 4 times 5. Out comes that 2, because you're looking for a group of 2. Out comes the square root of 4, which is 2. 2 times 2 is 4. And you left a 5 under there. Yeah? I know I'm going fast, but this should be review for every single one of you. Yeah? Bea. Are you allowed to do something completely different than me? Yes. Okay. I'm just making sure that that's okay. You don't need to change. If you know what you're doing, keep doing it.
I don't.
Okay. What were you taught? Okay.
So I'm just like trying to understand what you're doing. So when you take up the 2 squared, like why didn't you take that out?
I did. There it is right there, 2. Because 2, okay. What's the square root of 4? 2, right? 4 is also 2 times 2, yes? So because I'm looking for a group of 2, I take out a group of 2, and there it is. No, you're always taking a group of however big the index tells you. So root 2 squared, that squared means I'm taking out a group of 2, so out comes a 2. Now, if it was the cubed root of 8, now I'm looking for a group of 3, which would be 2 times 2 times 2, or 2 cubed, and the answer to all of that is 2. Because you're taking out a group of 3. Cool? Now wait, because everybody says that's great, and then I do this. What's the square root of 8? Now the square root of 8, that's 2 times 2 times 2, yes? But since I'm only looking for the square root, how big a group is coming out? A group of 2. So I bring out my group of 2, 2, root, but I left a 2 under there. Okay? Good? So just to make sure, the 4th root of 16, 2 to the 4th. So that equals 2. The cube root of 16, 2 to the 4th, would equal 2 cube root 2. Right? Because I brought out 3 of those 4 2's. And I left a 2 there. Good? Okay. And then the square root of 16 would be, I would take out, it's 2 to the 4th, so I can take out 2 groups of 2. 2 times 2 is 4, which is why the square root of 16 is 4. Cool? Okay. So 300, what are you going to break it down into? Logically, the first step. 3 and 100. Why? 100 has a square root. So this is 3 times 100. What's the square root of 100? So it's 10 root 3. Easy peasy lemon squeezy, right? What about 63? What are you going to use? 7 and 9. Square root of 9, 3. What did I leave under there? 7. Square root of 32. 16 and 2. Square root of 16, 4, root 2. And square root of 363, oh, barf, that's a big number. Doesn't divide by 2 because it's odd. So what's the next one we should try? What's the next? 3. How many times does 3 go into 3? Once. How many times does it go into 6? Twice. How many times does it go into 3? Once. Can I stop there? Why? What's the square root of 121? 11 root 3. See how much you can do in your head? Everybody is good? It doesn't get any more difficult than that. If you can do this, it doesn't matter what I put there, you can do radicals. Everybody's cool? Okay, turn the page over. Now, reverse the situation. 9 times out of 10, you would not ever do what I'm about to do. But sometimes it will help you. Okay? So we want to reverse the situation. We have a mixed radical. We want to go back to an entire radical. If there is a single 2 out here, how many 2's had to be under there? 2. So that is the root of 5 times 2 squared, which is the root of 20. Does everybody understand? So what is this one going to be? The root of 29 times what? 7 squared, which is 49. And I can't remember what number that is. It's a big number. I don't care. Doesn't matter. Everybody cool? This one would be the root of 4 times 6 squared, which would be the root of 144. And this one is tricky. What is going under there? 5 squared, not negative 5 squared. Because this answer, even though negative 5 squared and 5 squared are the same thing, this is a negative value, isn't it? So this has to be negative 12 times 5 squared, which is negative root 300. Everybody cool? Everybody can work both ways? What if I told you that this was the cubed root? Then it would be 5 times what? 2 cubed, which would be 5 times 8, which would be the cube root of 40. Everybody understand? What if I told you I wanted the 4th root of 5? What would it be? What would be here? 4. So it would be 5 times 16, which would be the 4th root of 80. Does everybody understand? Whatever the index is, that's the exponent of the coefficient that goes in there. Cool? All right. How could you, and this is key because I see people grabbing them already, how could you not touch your calculator but put these in numerical order? So no touching a calculator. Sophia. Absolutely, that is what we would do. This is 2, that's a highlighter, you idiot. This is the root of 2 times 7 squared, which is the root of 98, right? What's the next one? Now they're super easy to put in order, aren't they? Right? because isn't 9 the root of 81? So now we can put them in order, can't we? What's the smallest one? Smallest one right there. What's the smallest? Root 14. What's next? Root 36, which is really 3 root 4, right? So in order, we had root 14, then 3 root 4. What's next? $75, which is 5 root 3. What's next? 9, because root 81 is 9. And then what's last? 7 root 2. Everybody cool? Sweet. All right, so now you have 6 questions there. Do them. Be careful, look closely, because they have new indices. They are not square roots. Oh, except for f. F is a square root. Everything else has a different index, so you are looking for a different group. But you break them down the same way, right? Do I need to do the first one with everybody? 54. Most of you are going to break that down into 9 and 6, is my guess. Some of you could be wise asses and go 18 and 3. Some of you could be even more wise asses and go 27 and 2 and stop. Why? Why could I stop right there at my first branch? 27 has a cubed root. What is it? 3. So what's coming out right there? 3. 3 cube root. And what did I leave under there? 2. Now let's pretend that you didn't see that, just to prove to you that it's okay. 9 and 6, 3 and 3, 3 and 2. There's my group of 3 with a 2 left. Everybody cool? If the kid you sit beside, you look over, and they are only doing one branch, and you got to do all the branches, is that okay? Yes. Just means that kid has memorized some more perfect squares and cubes than you have. Right? Now, if that kid was sitting by me, would I be making more or less branches than that kid? I'd probably be making even less, because I know a lot more roots. Like I know some 4th, 5th, and 6th roots that I have just sitting around in my head. Like math garbage that hasn't been swept up and taken care of. Everybody understand? There is nothing wrong with having to go all the way through. Cool? Okay, go. What are we going to do with 144? Carry on. But it's cubed. It's not square, because I know somebody's already written 12 there. I want a cube root, not a square root. What is the only group of 3 I can get out of there? 2. And I had to leave 1 2 under there and 2 3s. So 2 times 3 squared. What is 2 times 3 squared? He waited patiently. 2 times 3 squared. Just waiting for somebody to multiply 2 times 9. Thank you. 128 with a 4th root. I'm going to stop there. Why? Because I've memorized that 16's fourth root is 2. Because knowing the 2 exponents is a really good thing to know. You remember how if you were in my grade 10 class, I said memorize the first 20 square roots and the first 10 perfect cubes? Knowing the 2 exponent series, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Knowing how 2 works is really useful in higher level math. Because 2 is the most powerful prime number, because it is often part of simplifying radicals. So I can stop there because I know the fourth root of 16 is 2. 2, fourth root, and what did I leave under there? These are all gone. So I left 2 cubed, which is 8. Everybody cool? 162. 2 and 81. I can stop there. Why? You obviously know the answer now. Why can I stop there? 81 has a fourth root, right? Because the square root of 81 is 9 times 9. And then 9 is 3 and 3 and 3 and 3. So there's 4 3's, right? 81 is 3 to the 4th. There's my group of 4. But if you don't know that, you just carry on. 9 and 9, 3, 3, 3, 3. There's your group of 4. 3, fourth root, 2. 108 is 4 times 27. Cube root of 27, 3. Cube root 4. Square root of 108, is 9 times 12. And a lot of kids right now will say it's 3 root 12. Is that right? No. Why not, Ellie? Right. This is 4 times 3, isn't it? So out would come a 2, so it's really 6 root 3. Everybody cool? So even if you know some perfect squares, you still have to check. Now, if you're really good with multiplying, you know that 36 times 3 is 108, and you could just take out that 6 right there. Is everybody good? Again, this is still review. Everybody's seen this in grade 10, right? Now remember, I said to a lot of people in the last unit when we were doing something like this, 18 to the 2/3. Right? Now you all know that's the cubed root of 18 squared, yes? And we talked about how if it was something like this, 8 to the 2/3, that would be the cubed root of 8 squared, right? And we talked about how you would just do this, because the cubed root of 8 is what? 2, right? And 2 squared is 4, right? And some people asked, well, does that 2 live outside there, or does it live under there? It's the same thing. Now, for this, the reason I didn't get into it in the last unit was because I knew we were doing radicals right now. Now, this 18 doesn't have a cube root, does it? Does it? No. So that 2 would come down under there, right? And then we would break this down, and we could go 9 times 2 times 9 times 2. And then 9 would be 3 times 3 times 2. 3 times 3 times 2. And there you can get out a group of 3. Or you could still leave it like this, simplify 18, but then you've got to square a radical, which we're about to teach you how to do, but most of you probably don't know that yet. Is everybody following me here? Like, this is what we're doing right now. Your group of 3 would come out. It would be 3 cube root. Those 3's are gone. And what would be left? 2 times 2 times 3, which would be 3 cube root 12, right? But if you do what we did last unit, and you put it out here, and you try to simplify this, 18 is 2 times 3 squared. Is there a group of 3 to come out of there? Is there? No. So you got to bring that 2 inside. Does everybody understand? Okay. What's going to be different here than what we've already done? On page 35. We've got a mixed, we want entire. Now we remember when it was 3 root 4, that meant we brought 3 squared under there, right? Well, what are we bringing under there now? 3 cubed times 4, because the index is now a 3. So that is the root of 27 times 4, which is the cubed root of 108. What's this one going to be? 5 times what? 6 to the 4th. Now 6 to the 4th is 1,296. 1,296 times 5 is a big number that I can't do in my head. 6,000 and then 96 times 5, 6,450, 6,480. Well, you would use your calculator to do that. I don't expect you guys to be doing 6 to the 4th in your heads. If you stop there, I'd still give you credit. Because I don't really care if you know how to use your calculator, right? This is the concept, isn't it? And what would this one be? Seven times 5 cubed, which would be 7 times 125, which would be 875. Yeah? 875. 700. Yeah, 875. Okay. So your job is to do up to the end of 36. Now, please remember, just look up here. You don't need to turn all the way to 36. You see some fractions here, yes? Remember, where does this 2 go? Does it go with the root? Or does the 5 go with the root? What math is happening right there? This is a coefficient, yes? No. Sorry. What math is happening between the yellow thing and the blue thing? Multiplication, right? So this is actually 2 over 5 times the root of 450 over what? 1. So where does the 2 live? With the 450. So this is 2 root 450 all over 5. Everybody understand? Where does that negative live? Can I put it with the 5? And put the 5 with the 304? Yes. Everybody cool? So your job is page 35 and 36, and you've got 4 days to do it. Because you've worked so hard this week, I'm giving you the next 4 days off. At double your pay. Okay? Plus, I'm giving you 36 minutes right now. So really, should you have any math to do for the next 4 days? No. Why? Grinchy heart. 2 sizes too big. Go have fun on your long weekends.